Thank you very much for inviting me to speak to you today. I was mentioning to the moderator that I had the wrong date on my calendar. I thought it was tomorrow, and fortunately, I received the email that it was time to sign in. I chose to speak today about advances in CSI and forensic science technology, and there are a wealth of things going on. We all recognize that science and technology doesn't stand still, continues to change, improve, get better. Some things that we did years ago are no longer in use. Some of the things actually have come full circle. The one thing I need to remind you about in using new technology is you have to be sure that it is checked out, vetted, proven, that it works as desired. Certainly, I know here in the United States, we have many court battles to demonstrate that the new technology that we're using is in fact reliable. So my advice to you, if you see or hear something that I'm talking about, make sure that it's adequately checked out in your own institutes before you jump in and start using it in casework. So let me first of all, I have to congratulate my Indian colleagues on India's landing on the moon. I think that's a phenomenal accomplishment, and it shows the prowess of Indian science and technology as it has grown to meet this particular achievement. My hats off to you. I salute you for a job well done, and I hope you can gather lots of new scientific data from the exploration. Today, I'm speaking to you from my home in Indio, California, which is located about 200 kilometers east of Los Angeles. I'm in a retirement community with golf courses, palm trees, and snow-capped mountains in the wintertime. It's in a desert, and unfortunately, during the summer, it can get up close to 50 degrees C. So it's great. It's great in the winter, but not so great in the summertime. Did I just lose you? Hold on. There we go. If you want to be in touch with me, if any of this stuff is interesting, I'm on LinkedIn and Twitter. I publish a lot of stuff there that I come across from the news, the media, scientific journals. I've also included my email address, barryajfisher@gmail.com. I find it really interesting to be able to talk with colleagues from around the world and share experience and try to answer questions, and also serve as a connector between people that I know here in the United States and elsewhere with people from other parts of the world. Hold on. I'm on the computer. Anyway, here's my story. I grew up in New York City, where I attended college. I have a bachelor's degree in chemistry and a master's degree in organic chemistry. I moved to Los Angeles in 1968 and was hired as a forensic chemist at the Los Angeles County Sheriff's Department, and worked in various fields in the department, and ultimately was promoted to laboratory director. Along the way, I also received a Master of Business Administration, an MBA, which I credit as being one of the reasons that I was successful in moving up my career. So let's talk a little bit about forensic science advances. And this list is by no means complete. There are all kinds of other things that I could have put up there. I tried to scratch the surface and give you an idea of some of the things that are out there. So consider this a partial list. It's certainly not an exhaustive catalog on everything that's new. And certainly, as I said, things are being added all the time. Forensic imaging has gained a great deal of interest here in the United States. One of the older, perhaps not that old, within the last 10 or 15 years, is using some devices that surveyists use to take a look at roads and what have you. One of these companies has developed devices that can come up with a three-dimensional representation of a scene, whether it's indoors or outdoors, and it's quite useful in using this information to explain to jurors what is going on. Some of these, in addition to looking at crime scenes, they can be used to enhance many areas by using different types of lights, and can be used to enhance blood stains and fingerprints and other sorts of trace evidence. So these survey equipment can be mounted, placed on a tripod, and used to show the various locations of items in a crime scene. And they have been shown to be very, very helpful in presenting evidence in a court to depict what was going on in the crime scene. It can be rotated around to give different positions, so the court can look and see what the perpetrator of a crime was looking at and what the victim of a crime saw as it was happening. So it's a very interesting and useful piece of equipment. One of the newest areas that I've come across, and I've seen some advertisements from Apple, they're getting into this business, and that's the top right-hand image. And it's using augmented reality to describe different locations. You can look through these goggles and view computer screens and take measurements and look to see what's going on. I think that these items, these goggles, will be very useful in training CSIs and police investigators how to process crime scenes, because they will view areas in a three-dimensional way and be able to also be connected to a computer, which they can view in these devices. So this is going to be a very useful piece of equipment that will be coming up in the next few years. DNA has seen a whole bunch of changes since its arrival in the forensic scene. When we first started with DNA, we were using RFLP technology. It was very, very slow to come up with answers to results. It sometimes could take as much as 2 to 3 weeks before a test result could be achieved. Now there is a new technology called rapid DNA testing, and results can be achieved within 2 hours, as opposed to the usual time today of about 24 hours. It's reported that this technology does have some challenges with mixture interpretation. And we really need to use trained technicians to run these tests. I know that some places are looking to put these in police cars and letting the uniformed police officers run these tests. And that, I think, would be a big mistake because the technology is still fairly sophisticated, and to put it in the hands of limited trained individuals could be a big mistake. So in addition to rapid DNA, there are a number of other developments that we've seen in recent years with DNA. Is genetic genealogy, which has become very, very useful here in the United States and elsewhere, where you can determine the identity of somebody by looking at close or near relatives and seeing commonality in parts of their DNA genome. And it's an effective way. We have solved here in California a number of very, very high-profile cases where the perpetrator had not been in the regular national DNA database, and through the use of genetic genealogy, the authorities were able to go into some commercial genetic programs that are out there that are open to the public, find close relatives, and that information was used to identify an individual. In a couple of cases, they followed the person around, waiting for him to dispose of something. One fellow was in a coffee shop, finished a cup of coffee, tossed it in the trash, and the police were right behind there collecting it, and they tested the DNA back at the laboratory and were able to clear a large number of cases. He had been involved in a number of rape, murder cases. Another area that's coming along is using certain portions of the DNA marker to determine physical characteristics, gender, race, stature, hair color, eye color. We're not to the point yet where we can take some DNA and put it into a machine and come up with a thorough likeness of an individual, but this is a start, and it's I wouldn't be surprised as this technology becomes more becomes better that there'll be possibilities of really getting a likeness of an individual just from the person's DNA. A curious example of DNA testing that I just came across in a research report out of a university in Florida was that they were able to get human DNA from pets. So if you had a pet dog or cat, for example, and you were petting him, some of your DNA would be sloughed off onto the animal's hair, and that could be tested. And there may be some useful cases that this kind of analysis may be worthwhile in terms of identifying a victim or a suspect in a crime. Who knew? That's all I can say. Another interesting technology that's being used, the difficulty, of course, is the cost of the technology is really prohibitive, but they're using MRIs to do virtual autopsies instead of doing the traditional autopsies. They're using computer imaging to do what you would do in a normal kind of autopsy, and without actually having to do dissections of the body. This technology, of course, may be of interest in cultures that do not allow or do not like to have decedents put through a traditional autopsy, and this may be okay for certain cultural and religious uses. So it's again it's been out there for a little while. Again, it's a very expensive way of doing it, but it does give some useful information. Automated identification systems are something that have been around for a while. APHIS systems, where fingerprint databases at the local, regional, and national level can be used to identify individuals. The technology is becoming more miniaturized. There's no reason to suspect that in a short period of time they'll be in police vehicles and perhaps even on smartphones, where a police officer stops an individual, asks him to put his thumb on the screen of a phone, and in a few short moments identify the individual based on a stored database. So that's probably something that's coming around. The scanners that are available are very high resolution, and the algorithms that are used there can quickly identify individuals that may be stopped by the police. Digital forensics is a very important new technology that's been in place for just a few years. There are all kinds of evidentiary material that are hidden in on computers. There is, of course, the possibility through artificial intelligence to abuse some images that you may see on a computer, such as a photograph or even a movie. And digital forensics is working towards trying to differentiate between a real image and a fake one. But in addition to that, there is the need to search computers for hidden information, whether it be documents or photographs that might be helpful in a criminal case. So this is something that is growing very quickly, and will certainly be a welcome tool in the future. Facial recognition is becoming more and more used to identify people in large crowds, or just to identify a single individual by the relationship of different aspects of the face. I included up here an old photograph of the Alphonse Bertillon process that was used in the late 19th century and even early 20th century, where police would measure different parts of an individual, the length of his ear, the distance between his eyes, his arm length, his finger length, and what have you. And it's curious, because this is one of the technologies that has come around, and instead of using measuring devices, we're using computers to come up with this useful information to identify people. The interesting thing is computers become more and more advanced, and the technology is such that you can search through large numbers of individuals and kind of identify them. I know I've seen reports that this is in pretty wide use in China, and it's an effective tool for identifying individuals. Oops. Back. Wait a second. Nanotechnology is a very new procedure. It's just getting started. It is using microscopic items of material to categorize and identify individuals. It has the potential of a whole host of different areas in the forensic realm. It hasn't gotten a great deal of traction yet in that area, with the possible exception of toxicology is using that to some degree. But this is a diagram I lifted off of the internet showing the different areas that nanotechnology might have some useful provide some useful information to the authorities, whether it be prints, DNA, toxicology, body fluids, gunshot residues, or explosives. These are all useful and potential things that nanotechnology can be used for. And the neat part about this is that you're able to test very, very small quantities of these materials, which is a good thing. But on the negative side, of course, you have the problem with potential cross-contamination. If somebody comes in contact with evidentiary material yet had nothing to do with a particular case, he could be wrongfully identified. Artificial intelligence. This is a very big area that's coming into play nowadays. You have digital forensics, which I mentioned. Artificial intelligence can examine large amounts of data and come up with some conclusions. Fingerprints and pattern recognition. Again, artificial intelligence will be a good use of pattern matching, whether it be fingerprints or footwear evidence, tire impression evidence, and such. Facial recognition, as I mentioned before, artificial intelligence can scan through large quantities of data to identify individuals. Voice prints, voice analysis. There have been some studies using artificial intelligence to clarify voices that have a lot of background information in the recording that make it difficult to understand what's happening. And this is a valuable use of artificial intelligence. Complex DNA mixtures, again, a form of pattern analysis may be useful in examining DNA that are degraded from degraded samples or mixtures. There are uses out there. There's a relatively new field, big data, large amounts of data. And if may be able to use this to process evidence, particularly in diverse cases. I've seen some reports for medical use where physicians can place symptoms into an AI application, and the AI application can search huge amounts of data to come up with some diagnoses that the physician may not have been aware of. Vehicles and crime scenes used to simulate and model reconstruction of vehicles involved in in traffic collisions, cold cases, looking at putting fresh eyes, if I could use that terminology, on information in old cases that perhaps could lead to additional information. Handwriting analysis, again, making use of pattern matching to take a look at different categories. I mentioned this business of big data, where artificial intelligence and computers are crunching huge amounts of information and using it to come up with conclusions or decisions in a variety of areas. It hasn't really taken off to a great extent in forensics, but I'm quite certain that you're going to see more of this so-called big data analytics to use in solving crimes. Drones have become almost ubiquitous. They're all over the place now, and the police have certainly made use of them to fly over areas with cameras attached to them to help document large crime scenes, look to search for victims and mass casualty survivors, which is probably more efficient that way than doing an on-the-ground search. And these drones can also be equipped with, in addition to cameras, UV and IR sensing devices, again, to help with a search of a particular area. This is not the newest of technologies because it's been available for some time. 3D printing to make crime scene models, evidentiary models, skeletal models, and whatnot. This is another area that is gaining application in the forensic and crime scene investigation world. And I think you need to keep your eye open for these kinds of materials. Immunochromatography. This is a relatively new technology that can examine small samples of evidence. There are even some smartphone based sensors or technology that can evaluate samples in the lab and in the field. The military and in battlefield forensics have used some of this technology to rapidly identify individuals in the field and also check on their medical conditions. Cloud forensics, just another one of these areas of utilizing big data. It enables you to store and access huge amounts of data and use it, have it distributed in various kinds of ways. Another useful technique that I recently came across was using hand odor to determine gender. It's kind of a curious thing, and I'm not quite certain how this might be used in a criminal investigation standpoint, but it's one of those things that are of interest that are probably going to pop up now and again. And the claim is that there's an accuracy of 96%, which I think is pretty good. Forensic ballistics or firearms identification. Here in the United States, we make a great deal of use of these IBIS systems, integrated ballistic identification systems, which can look at fired bullets and cartridge cases, and compare it with large databases. It's not conceptually that different from fingerprint databases or DNA databases. Again, the technology is on the expensive side, but in areas that have a lot of problems with gun-related crimes, this is a technology that can be useful in connecting weapons from one scene to another. So I've gone through a whole bunch of information, and I want to thank you for your time to listen to what I have to say. As I mentioned earlier, new technology is a huge area. There are new things coming up on a regular basis. You want to be critical in not just jumping in and using the first thing that comes along that looks to be promising, but to make sure you validate it and verify that it can do everything that it says. So with that, I'm going to stop sharing my screen